Hey guys, Joe from JB Custom Welding. This is my buddy Alex here, and we're making a video for you guys to try to help illustrate a new design we have that we think is going to be a better approach to tackling the problem you have right now with your goalpost. So Alex is kind of our mechanical engineer, and he's installed fill gold posts in the past. He's done all types of construction work, so he's got a mind for this type of thing. So we want to show you kind of what Alex has to say. So I'll turn it over to you, and I'll just talk with you as we go through it here.
I'm Alex, work with Joe on occasion, and this is a pretty interesting situation that he presented me with here today. So with the pictures that we've been provided and the situation that was explained to me, they're having a problem with the cross member of the goalpost being parallel and being able to adjust it, being able to maintain it. There's a couple of factors that cause that. One of the factors is that, if you can see here, this is the system that you have right now. This is your cross beam. This is your gooseneck, and you've got a collar in that gooseneck with a central fastener that goes through. So there's a great deal of force that's put on this fastener due to wind or whatever the forces are exerted on it that would be considered shear force. This fastener is made out of steel. The goalpost is made out of aluminum. So anytime this thing moves, wiggles, it gets any vibration or whatsoever, the metal that's going to fail is going to be the aluminum. The steel is going to maintain its diameter, it's going to maintain its shape. The aluminum is going to kind of meld around that steel.
Kind of waller itself out, right?
Basically, yeah. So over time, as this thing wobbles, that hole is going to get longer. It's going to stretch. You know, sometimes depending if it's an orbital action, it's just going to become a bigger hole. So instead of going back with that same situation and putting any more bolts in and bringing something through front to back, which you're going to have play in, I would propose doing a different system, which we also have illustrated here. Okay. So the plan that we have right now is, instead of having the bolt going through the two sections of pipe that are sleeved and trying to make the connection there, and having that union being central to that gooseneck, we want to bring those forces away from the center, away from the axis point. And we're also going to change the way those forces affect the cross beam in relation to the gooseneck. What we're proposing to do is using a system of two plates, as you can see here, which are not quite put together. What we're going to do, we're going to slide this one out, okay, and we'll drop that right behind there. Yep.
Okay, put him in.
Yep.
Yep, right there.
This is going to represent what you have right now as far as the connection is welded to the cross beam to the gooseneck that actually fits into the receiver of the gooseneck. And this is actually the gooseneck. So with everything that you've got in place, we're going to put together basically this arch here. This will be two sheets of metal that you can't really tell from this angle. But we're going to put two bolts in here just inferior to the cross member. And we're going to use friction to pinch these two plates together away from that center axis point in order to keep that force from moving the goalpost from the position that they want to be in. So once they get the thing fixed, it's not going to be able to wobble and move and affect it like you would be at a central axis point. It's going to basically reduce the amount of torque that's being placed on the fasteners, and the fasteners are not going to be the ones responsible for that torque as much as the two plates are in friction with one another.
All right. So Alex, one of the things we're looking at doing over here, so if we're going to try to help illustrate this off what we're thinking about here. So if we can say, this here is the long cross member right here, and here's that little
piece.
The little piece right here coming off. That and then this piece here represents the gooseneck right here.
Yep.
As these guys are right now are sitting right here really close together.
We need a smaller, we need about half of this so that we can show one side.
Yeah, and essentially what we're going to do is these two plates here, they're going to be made out of, obviously made out of aluminum. They're going to be much thicker than this. This is just for a demo purpose. But we're going to go ahead and cut these two plates down. And we're going to make like a nice little arch in here so that we can then take the plates underneath and sit it around both the gooseneck piece as well as the attachment piece right here. Essentially, basically, we're going to help start to form a collar. And as this plate, which I'm just going to show it up here for just illustration purposes right here, you can imagine it right here. Move this here. Here's our attachment piece here. If you can imagine, this plate has been cut off so they can sit around the attachment piece here. We're going to come up probably about halfway up here. We're going to weld around here. And right here where the plate comes behind the goalpost, we're also going to make the weld attach points out here. Again, trying to help make that smaller pivot point, make it wider to help reduce some of the leverages against it. And then the way for you guys to help line the pieces up, there'll be a hole in here and here. We will put the second piece shows up right here again. This piece would also be cut out and will be welded underneath the gooseneck right here. And the holes will all, if you can imagine, the plates will actually be touching each other with the two bolts running through it. And then essentially crank that up. Does that make sense here?
Cool. So, like we showed on the picture here, we've got a plate that's going to be attached to the cross member and a plate that's going to be attached to the gooseneck. Essentially 2 plates right up against each other that'll be manufactured in the house here to be true, and then welded in place once we get there to the field with two
bolts.
You know, 2 anchor points. So it wouldn't be anchor points, but it would be 2 connections.
So
you have these 2 connections at the corner, or it could be any connections you want it to be, but two would definitely suffice for what you're doing here.
So when they want to take it down, all they have to do is just remove those 2 bolts right there.
And these bolts would be 1.5 inches long, as opposed to something 7.5 inches long that you're trying to connect everything, you know, through the pipe with. We transfer all that to a set of plates, which would look like this right here.
If you want to come down here and shoot down to the side here.
I'm going to step to the side. So essentially what would happen, if you can visualize this being part of the cross member, kind of like what you have there at the field, and this butting against another section of pipe, one section of this plate would attach to the cross member on this side, would weld across the top, would stick down just slightly below, just enough to get the bolts through it, and then this other section of plate would actually weld to the gooseneck where the cross member receives it, and would be welded around that, around the pipe itself, essentially creating a collar. And then your connection points will be away from the center of that pipe. Using friction, you'll connect through here as opposed to connecting through here. And you're going to get rid of that shear force using the connectors, and you're going to use, everything's going to become friction. It'll be a friction connection as opposed to a shear connection.
Right, so okay, so this basically these guys, there will be 2 plates here. Imagine this plate being cut out and this piece sitting all the way firmly against the pipe. That front plate will be welded to this connection piece here, and it as well be welded out here. That second plate will only be welded around the gooseneck itself up here. So basically, you just separate those 2 bolts, the plates, then you can detach the upright, the cross member, and then because those plates will be drilled together, when they come to put it back up, that we can have super tight tolerances where those bolts are at.
Correct. And
not have to worry about trying to come through and line it up straight. It'll just be nice and tight right there and be quick and easy to take apart.
And when you do the install, once you fabricated the collar that's going to go on the goalpost, you get the goalpost perfectly set like you want it to be set. You're going to get that cross member level. This is going to go in place after it's been leveled, and it's going to have something that returns to true 0.
Yes.
So as soon as you put it together, as soon as it's welded up, it's going to return to absolute 0 every time you put it together.
That's right. That's right. So hey, just want to recap real quick with you guys. So essentially, kind of the takeaway points here. One, I think it would be easier for you guys to take the field goal post down. Also, this also keeps us from having to try to drill through the cross member. It's just going to be very difficult to get that through perfectly without creating a little bit of wallowing on each of the ends. So this way it avoids that altogether. I think it'll be less noticeable from the front. You won't see the bolts coming through if you're on the field looking towards the field goal post. Also, one of the things that if the holes where the new brackets come through, if they wear out, we can always replace them with a new bolt, a slightly bigger bolt. Makes it a little bit more scalable. And I think that's pretty much it. So hopefully this explains it well. Thanks, guys.